Hello everyone. Today I'm going to discuss on the topic of Java collections. So let's begin. Java Collections Framework. The Java Language API provides many of the data structures from this class for you. It defines a collection as an object that represents a group of objects. It defines a collection framework as a unified architecture for representing and manipulating collections, allowing them to be manipulated independent of the details of their representation. There are so many collection frameworks. Like we have collection interfaces which represent different kinds of collections such as sets, lists, and maps. These interfaces form the basis of the framework. The next collection framework is general purpose implementations, primary implementation of the collection interfaces. Then we have legacy implementations. The collection classes from earlier releases, vector and hash table, have been retrofitted to implement the collection interfaces. There are wrapper implementations too. Add functionality such as synchronization to other implementations. Convenience implementations, high performance mini implementation of the collection interfaces. Abstract implementations, partial implementation of the collection interfaces to facilitate custom implementations. Algorithms, static methods that perform useful functions on collections, such as sorting a list. And then we have collection framework on infrastructure, so like interfaces that provide essential support for the collection interfaces. And then we have array utilities, utility functions for arrays of primitives and reference objects. Not strictly speaking a part of the collection framework, this functionality is being added to the Java platform at the same time and released on some of the same infrastructure. So first, beginning with collection interfaces. The core collection interfaces encapsulate different types of collections. They represent the abstract data types that are part of the collections framework. They are interfaces, so they do not provide an implementation. Okay, so as you can see here in the chart, collection interface has these many data structures, like we have set, list, queue. Inside set we have sorted set, and we have also map. Inside map we are having sorted map. Moving forward, public interface collection extends iterable E. Collection, the root of the collection hierarchy. A collection represents a group of objects known as its elements. The collection interface is the least common denominator that all collections implement and is used to pass collections around and to manipulate them when maximum generality is desired. Some types of collections allow duplicate elements and others do not. Some are ordered and others are unordered. The Java platform doesn't provide any direct implementations of this interface, but provides implementation of more specific sub-interfaces such as set and list. As you can see here, we have an implementation of interface collection here. So you can see public interface collection E. E is here generic, extends iterable E, and then we have some basic operations and some bulk operations and some array operations. So what we are doing here, we are extending the iterable class, and we are extending the iterable class in the interface collection. A note on iterators. An iterator is an object that enables you to traverse through a collection and to remove elements from the collection selectively if desired. You get an iterator for a collection by calling its iterator method. The following is the iterated interface. So we have an iterator interface where we have a boolean has next method which gives us the information that there are elements present in a particular data structure. And then we have a next method, and also we have a remove method, which is optional and is not used most of the time. Talking about the set interface, it also extends the collection class. Collection that cannot contain duplicate elements. This interface models the mathematical set abstraction and is used to represent sets such as the cards comprising a poker hand, the courses making up a student's schedule, or the process running on a machine. All can be stored inside a set. This is the implementation of the set interface, and it also extends the collection class. As you can see here, we have basic operations like we have size method to to find out the size of the set. There is empty method, contains method, add method, remove method, and there is one iterator method. Also some bulk operations are there which contains all, add all, remove all, retain all, and clear. Some array operations are also there, like to convert the object to array we use toArray method, and so on and so forth. We have to note one point, that nothing added to collection interface except no duplicates allowed. Now we will talk about the list interface. It also extends the collection class and is an ordered collection, sometimes called a sequence. Lists can contain duplicate elements. The user of a list generally has precise control over where in the list each element is inserted and can access elements by their integer index or position. If you have used vector, you are familiar with the general flavor of list. This is the implementation of list interface. As you can see, it extends the collection class, and some are the positional access here, like we can get the index. If we can get the element from the index, we can set the element to the index, we can add an element to the list. Also we can find out whether that element is present or not. We remove an element from the list, and like the previous set also, the set interface, we have so many positional access, search and iteration and range view methods which are present in the collection class. Like you can see, we have remove, add all, index of, last index of, list iterator, and then sublist. A note on list iterators. The three methods that list iterators inherits from iterator are hasNext, next, and remove. Do exactly the same thing in both interfaces. The has previous and the previous operations are exact analogues of hasNext and next. The former operation refer to the element before the implicit cursor, whereas the latter refer to the element after the cursor. The previous operation moves the cursor backward, whereas the next moves it forward. The next index method returns the index of the element that would be returned by a subsequent call to next, and previous index returns the index of the element that would be returned by a subsequent call to the previous. The set method overrides the last element returned by next or previous with the specified element. The add method inserts a new element into the list immediately before the current cursor position. Now you will see the implementation of these at the bottom of the slide. You can see there is hasNext method, next method, and hasPrevious method, previous method. We have next index method, previous index method, and also we have remove, set, and add method. Now you might be aware of the set and add and remove and all these methods and their functionalities, right? Now we'll talk about the interface queue. Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. This is the implementation of the queue interface where it extends the class of collection. We have these many methods inside the queue interface. As you can see, we have element method, peek method, offer method, remove method, and poll method. Talking about map interface. An object that maps keys to values. A map cannot contain duplicate keys. Each key can map to at most one value. If you have used hash table, you are already familiar with the basics of map. This is the implementation of interface map. As you can see, the basic operations consist of put, get, remove, contains key, contains value, size, and is empty methods. These are the basic operations which we perform using the map interface. Now we also have bulk operations like put all and clear. Talking about the collection views, we have set. We can ask view from the map entry or entry set method. We can use key set method, values method. These are the collection views of the map interface. Interface for entry set elements, we have key, get value, and set value. Talking about the interface sorted set. Sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are used for naturally ordered sets such as word lists and membership roles. This is the implementation of sorted set. We have few methods. As you can see, we have subset, head set, and tail set methods. And also for the value of endpoints, we can use first and last method. Comparator access is also present using the comparator method. Note on comparator interface. Comparator is another interface in addition to comparable, provided by the Java API, which can be used to order objects. You can use this interface to define an order that is different from the comparable or natural order. There are interfaces like sorted map. It extends the map. So as I have already shown you the chart where sorted map was extending the map class. So this is the same part. Sorted map is a map that maintains its mapping in ascending key order. As it is map, so it has to maintain the key order, right? This is the map analog of sorted set. Sorted maps are used for naturally ordered collections of key or value pairs such as dictionaries and telephone directories. This is the implementation of sorted map. We are having the interface sorted map and it extends map. And sorted map has for these many methods which we can use, like we are having submap, head map, tail map, first key, last key, and comparator. Moving forward, this is the general purpose implementation of interfaces. Like if we see, we have interfaces of set, list, queue, and map. So if we want to implement set, then what are the implementations or interfaces which we have to implement? So these are the implementations. We can use hash set, we can use tree set if we want a sorted set, and we can use linked hash set if we want hash table plus linked list. Talking about the list interface, we are having array list, which is the resizable array. and linked list, which is linked list in the implementation part. For queue, we do not have anything, and for map, we are having hash map, tree map, and linked hash map. Linked list also implements queue, and there is a priority queue implementation implemented with heap. So what we do whenever we write a queue interface, we implement the linked list. Implementations. Each of the implementations offers the strengths and weaknesses of the underlying data structure. What does that mean for hash table, resizable array, tree, linked list, hash table plus linked list? Think about these trade-offs when selecting the implementation. Choosing the data type. When you declare a set, list, or map, you should use set, list, or map interface as the data type instead of implementing class. That will allow you to change the implementation by changing a single line of code. As you can see here, we are declaring a set SS named SS, and we are using a new linked hash set here. So by using this line, we do not need to implement a class here. We have used a data type instead of implementing the whole class. So we can use now set here as the one. If we would have if we would have implemented the class, then the same must have happened. But as we are using a data type here, we can use the set like the same as before. So we can use data type. Okay. Now this is the implementation of map data type. So when we declare a map using a new hash map, then we can use map.put to put the values inside the map, and then we can print that using map.get function. Other implementations in the API, wrapper implementations delegate all the real work to specified collection, but add or remove extra functionality on top of what the collection offers. Synchronization wrappers, unmodifiable wrappers, convenience implementation are mini implementations that can be more convenient and more efficient than general purpose implementations when you don't need their full power. List view of the array, immutable multi-copy list, immutable singleton set, empty set, list and map constants. You can use this chart for your reference whenever you are trying to implement any data structure. Have a look. We have collections, set, list. Inside set we are having sorted set, abstract set. Inside sorted set we are having tree set. In set we are having abstract set, and that we are having hash set, linked hash set. Then abstract collections are there for abstract set and abstract list. For list we are having abstract list. For abstract list we are having vector and array list. For vector we are having stack. For abstract list we are having abstract sequential list and linked list. For looking into the below picture, see we are having map interface, and then we are having sorted map, and also abstract map. Abstract map is an abstract class. And talking about tree map and hash map, it is concrete classes, and then we are having linked hash map. You can use this picture as a reference for further uses. Making your own implementations. Most of the time you can use the implementations provided for you in the Java API. In case the existing implementations do not satisfy your need, you can write your own extending the abstract classes provided in the collections framework. So as I have shown before, uh, in that chart you can use those abstract classes and implement um, your own needed implementations. At the last, talking about algorithms, so the collection framework also provides polymorphic versions of algorithms, so you can run on collections like sorting, shuffling, routine data manipulation for reversing or fill copy, for binary search, for frequency and disjoint compositions, for minimum and maximum finding extreme values, we can use collection frameworks of Java API. So that was all from my side. Thank you for joining and thank you so much.